Hello, my dear students. Today the topic I am going to discuss now is phasor and phasor diagram. Phasor and phasor diagram. This is one of the topic in the electromagnetic induction and alternating current chapter. Okay, the topic is phasor and phasor diagram. Right. Before going to discuss this, first what is meant by alternating voltage or alternating current? Already alternating current and alternating voltage are discussed in the previous class. Right. What is meant by alternating voltage? The voltage which continuously changes, or the voltage whose magnitude and direction is continuously changes with the time. Then the voltage is called alternating voltage. The voltage whose magnitude and direction is continuously changes with respect to time is known as alternating voltage. Similarly, the current whose magnitude and direction is continuously changes with the time is known as alternating current. Okay, alternating voltage and alternating current. The alternating voltage or alternating current is represented by like this. So this is graphical representation of alternating voltage. Right. Likewise, the graphical representation of alternating current is like this. Okay. So this is alternating voltage and this is alternating current. Okay. Why it is called alternating voltage and alternating current? Because the magnitude of voltage and the direction of voltage is continuously changes with the time. So that is why this is called alternating voltage. Right. Similarly, the magnitude and the direction of a current also changes with respect to time. So that is why it is called alternating current. So this is alternating voltage and this is alternating current. Right. This alternating voltage and alternating current is in the form of a sine wave. Okay, this is a sine wave. Is in the form of a sine wave. So this alternating voltage is also called sinusoidal alternating voltage. Sinusoidal alternating voltage. Right. This is sinusoidal alternating current. Sinusoidal alternating current, right? Because this voltage is alternatively changes its direction with respect to time. So that is why it is called alternating voltage. And the waveform of alternating voltage is in sine function. So that is why it is called sinusoidal alternating voltage. So this is also in the form of a sine wave. So that is why this current is called sinusoidal alternating current. Right. So this sinusoidal alternating voltage and sinusoidal alternating current can be represented by a vector. Okay. Suppose like this. Right. Suppose this is origin. Origin is denoted by O and the given vector is represented by OA vector, right? So this sinusoidal alternating voltage and sinusoidal alternating current can be represented by a vector, right? So if the alternating voltage or alternating current is represented by a vector, suppose which rotates about a fixed point or about an origin with a constant angular velocity, then this vector is called phasor. Right? If the alternating voltage or alternating current, sinusoidal alternating voltage or sinusoidal alternating current is represented by a vector which rotates, about a fixed point, or which rotates about an origin with a constant angular velocity, then the vector is called phasor. That rotating vector is called phasor. So phasor is nothing but a rotating vector which represents alternating, means sinusoidal alternating voltage or sinusoidal alternating current. Are you clear? Okay, simple. Phasor is nothing but a rotating vector. Because this vector rotates about a fixed point with a constant angular velocity. What is angular velocity? The rate of change of angular displacement is called angular velocity. Suppose this is a reference axis. Okay, reference axis. Right. Suppose initially this vector lies along the reference axis. After the time interval of t, it becomes in this position. Okay. This vector makes an angle of theta with respect to reference axis. Right. The rate of change of angular displacement is known as angular velocity. Angular velocity is denoted by omega. It is given by theta divided by t. What is angular velocity? Rate of change of angular displacement is called angular velocity. Right. Suppose in 1 second the angle made by this radius vector with respect to reference axis is, for example, 1 radian. Then angular velocity of this vector or of this phasor is 1 radian divided by 1 second. Then angular velocity of the phasor or angular velocity of the given vector is 1 radian second inverse. Right. And after another 1 second, the phasor comes from this position to this position and makes with the same angle, that is theta is equal to 1 radian in the time interval of 1 second. Now also the angular velocity is 1 radian second inverse. Okay, likewise, if the angular displacement of the vector with every unit time, that is every 1 second, is 1 radian, means then the angular velocity value is 1 radian second inverse. That value is a constant. If the given vector rotates about a fixed point with a constant angular velocity, then this rotating vector is called phasor. So once again I repeat, phasor is nothing but a rotating vector which rotates about a fixed point with a constant angular velocity. So what is the use of a phasor? The phasor is used to represent sinusoidal alternating voltage and sinusoidal alternating current. Right. Phasor means a rotating vector which is used to represent alternating voltage and alternating current. This rotating vector rotates about a fixed point with the constant angular velocity. Right. Okay, here in this diagram, just to see this diagram. In this diagram, this region represents alternating voltage. Alternating voltage can be represented by a graph like this, and alternating voltage can also be represented by an equation. Okay, the equation for alternating voltage, that is a sinusoidal alternating voltage, is V is equal to Vm sin omega t. Okay, the equation for sinusoidal alternating voltage is V is equal to Vm sin omega t. V the voltage or voltage at any instant. V suffix m, the peak value of alternating voltage. Peak value of alternating voltage. Omega is angular velocity or angular frequency of the alternating voltage. Angular frequency of the alternating voltage. What is angular frequency? Angular frequency of the given alternating voltage is equal to 2 pi times of the linear frequency of the alternating voltage. 2 pi times of the linear frequency, 2 pi times of the linear frequency of the alternating voltage is called angular frequency of the alternating voltage. Angular frequency of the alternating voltage. What is linear frequency? The number of cycles completed by 1 second. The number of complete cycles or the number of cycles completed by 1 second or unit time is called linear frequency. Okay. Suppose if in 1 second the number of cycles, this is one complete cycle. This is one complete cycle, one positive cycle and one negative cycle is there, means then it means it is one complete cycle. So number of this kind of complete cycles produced in the alternating voltage in 1 second means then it is called the linear frequency of the alternating voltage. Linear frequency of the alternating voltage. So 2 pi times of the linear frequency of the alternating voltage is called its angular frequency. Angular frequency. Omega is the angular frequency of the alternating voltage and T is the time. T is the time. So this is equation of sinusoidal alternating voltage. This is waveform of sinusoidal alternating voltage. This waveform of sinusoidal alternating voltage can be represented by a vector. Okay, this is a vector. Okay, and this rotating vector or this vector, that is OA, rotates about a fixed point, that is origin O, with constant angular velocity. In which direction? Anticlockwise direction. A vector which rotates about a fixed point or a fixed origin with the constant angular velocity in anticlockwise direction, not clockwise direction, in anticlockwise direction, then it is called phasor. Okay, this phasor represent this alternating or sinusoidal alternating voltage. Right. If the phasor is drawn in such a way that the length of this vector or the length of this segment represent or gives the peak value of sinusoidal alternating voltage. The length of the segment in this given phasor represent the peak value or the maximum value of sinusoidal alternating voltage. Right. And second, here the angular velocity of the rotating phasor or the angular velocity of the rotating vector is equal to the angular frequency of the sinusoidal alternating voltage. The angular velocity of the given phasor is equal to or gives the angular frequency of the alternating voltage. That is, angular velocity of the rotating phasor is equal to the angular frequency of the alternating voltage. For example, already I told angular velocity is nothing but rate of change of angular displacement. Right. Suppose this phasor completes one revolution. Then angular displacement of this phasor becomes pi. If the given phasor completes one cycle or one rotation, then angle made by this phasor or vector is equal to pi radian. Right? Suppose it completes one cycle in 10 milliseconds. Within 10 milliseconds, this rotating vector completes one rotation. For one complete rotation, angular displacement value is pi radian, that is 180 degree or pi radian. Right. So theta value is pi, and time taken by the vector to complete one rotation is 10 milliseconds. For example, 10 milliseconds. So 10 millisecond means 10 into 10 power minus 3 second. 10 into 10 power minus 3 second, right? We know that pi value is either 180 degree or 3.14 radian. 3.14 radian divided by 10 into 10 power minus 3 or 3.14 divided by 10 power minus 2. If 10 power minus 2 goes to numerator, it becomes 10 power plus 2. 10 power plus 2 is nothing but 100. 100 into 3.14, 314. So 314 radian second inverse. Suppose this is angular velocity of the phasor. Angular velocity of the phasor or angular velocity of the rotating vector. Angular velocity of the rotating vector, right? And here omega is the angular frequency of the alternating voltage, sinusoidal alternating voltage, which is equal to 2 pi times of linear frequency. 2 pi times of linear frequency. Suppose the number of cycles completed by the alternating voltage in 1 second is suppose 50. Then the linear frequency of this alternating voltage is 50 hertz. Okay, so this is one complete cycle, right? And the number of cycles completed in the given alternating voltage is 50 in every second, in every unit time, means then its frequency is 50 hertz. Okay, here the frequency of this alternating sinusoidal alternating voltage is, for example, 50 hertz, right? So 2 into pi value 3.14 and the frequency value is 50. Right, 50 into 2, 100, 100 into 3.14, 314, same radian second inverse. Right, here the angular velocity of the rotating vector is equal to the angular frequency of the alternating voltage. The angular frequency of the alternating voltage. If the phasor is drawn in such a way that the length of this segment represent the maximum value or peak value of alternating sinusoidal alternating voltage. The length of the line represent the peak value of or maximum value of a sinusoidal alternating voltage. And the angular velocity of the rotating phasor is equal to the angular frequency of the alternating AC voltage. Angular frequency of the alternating AC voltage. Right. And next, the projection of the phasor. This is a projection. This projection is drawn on this vertical axis. So this is vertical axis, this is horizontal axis, and this is vertical axis. The projection of phasor on any vertical axis, gives the magnitude or the voltage of the, the magnitude of the alternating voltage at that instant. The magnitude of the alternating voltage at that instant. Okay, understand? The projection of phasor which is drawn on any vertical axis, represent the voltage at a given instant or voltage at a given instant or at any instant, right? Suppose if the phasor comes in this position, then the projection becomes here. Now, at that instant, the magnitude of alternating voltage is this value, right? Suppose if the phasor comes in this position, and it becomes maximum value. So the projection of a phasor which is drawn on vertical axis gives the voltage at a given instant. Right. And next, the angle made by this phasor with respect to reference axis. Generally, the positive x-axis is taken as a reference axis. This is a reference axis. Here, angle made by this phasor with respect to or with reference axis gives the phase of the alternating voltage. What is phase? Phase is a term which represents the direction of motion and the position of the alternating voltage at any instant or given instant. Okay, the phasor is nothing but it is a term which represents the direction of motion and the position of alternating voltage at a given instant. alternating voltage at a given instant. Suppose if the direction of motion is either in this direction or in this direction or in this direction, okay, which is represented by a phase, okay, and the position, okay, position means here magnitude. So phasor is a term, phase is a term which represent the direction of motion or position of alternating voltage at a given instant. Here the angle between phasor and the reference axis gives the phase of the alternating voltage. Right. The purpose of phasor introduction is that to analyze the phase relationship between current and voltage in different AC circuits. Okay, to analyze the relationship between the different AC physical quantity, that is current and voltage in a different circuit, can be analyzed by using the term called phasor. So phasor is a term which is used to analyze the relationship between current and voltage in a different circuit. So these are the important or special features of phasor, right? So let I recall from the beginning. So phasor is nothing but a rotating vector which rotates about a fixed axis with a constant angular velocity, which is used to represent sinusoidal alternating voltage or sinusoidal alternating current. If the phasor is drawn in such a way that the length of the line or length of the segment gives or represent the maximum value of sinusoidal alternating voltage. So this is first point. Right. Second, the angular velocity of the phasor is equal to the angular frequency of the alternating voltage or alternating current. The angular velocity of the phasor is always equal to the angular frequency of the sinusoidal alternating voltage or sinusoidal alternating current. So this is second point. Right. And third, the projection of a phasor, on any vertical axis, gives the instantaneous value of alternating voltage. The instantaneous value of alternating voltage or instantaneous value of alternating current. The projection of a phasor. So this is a projection of phasor. Which is drawn on vertical axis, which represent the instantaneous value of alternating voltage or sinusoidal alternating voltage. Right. This is that point. And fourth one, the angle between phasor and the reference axis. Gives the phase of the alternating voltage or phase of the alternating current. So these are the physical features of phasors. Right. Phasor is a vector which rotates about a fixed point with the constant angular velocity. Is called phasor. Phasor is a vector which rotates about a fixed point with a constant angular velocity in anticlockwise direction. Is called phasor. Right. Phasor is used to represent either sinusoidal alternating voltage or sinusoidal alternating current. Right. Here the line OA gives the peak value of sinusoidal alternating voltage or peak value of sinusoidal alternating current. Right. The angle made by this phasor with the reference axis gives the phase of the alternating voltage. And the projection of a phasor on the vertical axis gives the instantaneous value of alternating voltage. Suppose this is sinusoidal alternating voltage which is applied to any one of the AC circuit. Okay, suppose for example this is the symbol of AC. Suppose it is connected or applied to a resistive circuit. So this is a resistor which is connected to an alternating source. This is a symbol of alternating source. Okay, which provide instantaneous voltage of V is equal to Vm sin omega t. This is graphical representation of a sinusoidal alternating voltage. This is equation of a sinusoidal alternating voltage. Right. This sinusoidal alternating voltage is applied to the AC circuit. And this is represented by a vector. Right. Here OA is length of the segment which represents a peak value of alternating voltage, and the angle made by this vector, that is a phasor, with the reference axis gives the phase of the alternating voltage, and the projection of a phasor on the y-axis. The projection of a phasor on the y-axis gives instantaneous value of applied voltage or alternating voltage. Instantaneous value of alternating voltage. Right. Okay, pi is a phase of the alternating voltage. This phasor rotates with the constant angular velocity. If the phasor completes one rotation, one complete waveform is produced like this. Okay, if the phasor rotates from this reference axis and it completes one cycle or it completes one rotation, then one complete waveform is generated. Right, phasor over. Next we go for phasor diagram. So phasor diagram means a diagram which shows various phasors, and their phase relations. Is called phasor diagram. So this is a phasor diagram. Okay, this is also phasor diagram, but in this diagram there is only one phasor. If more than one phasor can be drawn like this. Okay, this is current phasor, this is voltage phasor, right? A diagram which shows various phasors, okay, and their phase relationship is called phasor diagram. Right? So in this phasor diagram, this is voltage phasor. It is represented by OA. The length of the segment gives the maximum value of sinusoidal alternating voltage. And OB is a current phasor. Here OB represents the maximum value of sinusoidal alternating current. Right? Suppose if the alternating voltage is V is equal to Vm sin omega t, which is applied to the given AC circuit. If the alternating voltage is applied to the given circuit, an alternating current flows in the circuit. That alternating current, suppose represented by I is equal to Im sin of omega t plus pi. I is equal to Im sin omega t plus pi. Whenever the alternating voltage is applied to any AC circuit, an alternating current definitely flows through it. Suppose the alternating current flows through the circuit is I is equal to Im sin omega t plus pi. Here Im, peak value of alternating current, omega t, the phase of the alternating current, and pi is a phase difference between this alternating voltage and the alternating current. This is alternating current, this is alternating voltage, and pi is a phase difference between alternating current and alternating voltage. In this diagram, it is clear that this alternating current leads the voltage by the phase angle of pi. Alternating current leads the voltage by the phase angle of pi. That is, lead means forward, and the voltage comes backward. Right? Suppose if the alternating current in the given AC circuit is I is equal to Im sin of omega t minus pi means, then this circuit becomes like this. Instead of this part, like this. So this is phase difference between current and voltage. Here the voltage is in forward but current is in backward. So in this diagram represent the voltage leads the current by the phase angle of pi. The voltage leads the current by the phase angle of pi. But in the previous diagram, current leads the voltage by the phase angle of pi. If a current lead means, then alternating current flows through the AC circuit is I is equal to Im sin of omega t plus pi. If voltage leads in the given AC circuit mean, then alternating current, that is sinusoidal alternating current, is given by I is equal to Im sin of omega t minus pi. Right. So phasor is a rotating vector which rotates about a fixed point, with the constant angular velocity in anti-clockwise direction. Phasor diagram means the diagram which shows various phases. Various phases means current phasor, voltage phasor, and power phasor, various phasor, and their phase relationship. Okay, which is lead, either current lead or voltage lead. So these things are represented by a simple diagram. It's called phasor diagram. Right. Thank you, student. We will see you in the next class.